In order to simplify this rational expression, what you're looking for is things that you could cancel out because it's the same top and bottom. And what you notice as you look top and bottom, well, I notice right away, don't those x's, isn't x over x 1? And 1 times anything kind of just, the 1 becomes obsolete. So we call it canceling, but we're crossing out those x's. Can anything else disappear? Not exactly, but there's something very close to disappearing, but nothing else at this point can. So I am now going to simplify and rewrite things so maybe I could cancel out or eliminate some more pieces. So let's look at the 8 and 32. What's the GCF of 8 and 32? Hopefully you can tell it's 8. So the top will have an 8, and the bottom will be 8 times what? Gives you 32. 8 times 4. Okay, so I broke down 8, and this is 8 times 4. Now here, this doesn't eliminate with anything, so let's rewrite that. Let's rewrite the x plus 7. Now, I have an x plus 7 here, but I have a 7 plus x. Are those very close? Aren't these really close? Are we allowed to change this to an x plus 7? If you have 7 plus x, can you legally just change it to x plus 7? Yeah. So if I write that as x plus 7, will something eliminate or disappear? Can't you tell these now eliminate? Cross out because they're the same top and bottom, creating a 1. Can anything else drop out? Can't the 8s drop out? Anything else? You might think these are the same, but if you have a minus, there's a big difference between minus and add. You can't cross those out. So we are stuck with this. X plus 5 on top. Don't forget the 4. There's a 4 on the bottom still, and the 3x minus 5 on bottom. That would be my simplified form. You can't try and cancel out these or these. That right there is as small as we can go. Alrighty, to simplify this one, let's pull out greatest common factors. So for the top, what's the GCF of 10 and 25? Hopefully you can tell that's a 5. And what's the GCF of m cubed and m squared? Hopefully you can tell that's m squared. So when I pull out 5m squared from both pieces, 5m squared times what gives you 10m cubed? Hopefully you can tell that's 2m. 5m squared times what gives you 25m squared? Hopefully you can see that's minus 5. So we pulled a GCF out of the top. Can we also pull a GCF out of the bottom? What goes into both these? Hopefully you can see it's 10m. And what's left over when we pull out 10 from both these? You hopefully see it's 2m. And when we pull a 10m out of this one, 10m times what gives you this? Looks like negative 5. Do you see anything same top and bottom that we can cross off? Hopefully you can see these. So we're now left with this. Now 5 and 10, do 5 and 10 have something in common? Yeah. So can I write this 5, and on the bottom can I do 5 times 2 instead of 10? Now can I also, don't these show an m in common? So can I write that as m times m over m? Isn't m squared m times m? So could I now get rid of those two in a second? So can I 5s disappear? Can the m's disappear? And what we end up with is just an m over 2. All that breaks down to m over 2. Now, what does m over 2 represent? My simplified version. And what is useful about a simplified version? Here's something to think about. If I were to plug 12, for instance, right here, 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 and here, would that be annoying to calculate? If I put 12 on all those? But would it be easier to put 12 here? What's 12 divided by 2? 6. Did I do my math really fast? This simplified version, when you plug in 12, does the math fast. If I put 12 in this one, it'd be like, oh, no, please don't make me do that. But you plug 12 here, 6, done. A simplified version makes it really easy to plug numbers into. And simplifying things is a good thing in math. For this last one, we're going to simplify it. Now, you might think the 3x's or the 5's will disappear, but you can't because they're connected by minus. So it looks like nothing disappears. But watch this. I can leave the top still as 3x minus 5. But on the bottom, do you notice you could pull out a negative 1? And if I pull out a negative 1, do you notice that would be negative 5 plus 3x? Now, you might not realize how that helps, but watch this. Doesn't that become 3x minus 5 over negative 1? And can't I flip-flop these because of the plus now between? And make that 3x minus 5, and guess what? Do you notice they match now? Sometimes by pulling out a negative, you can make a match. They're very close just by a negative change. If you pull out a negative, they match. So those disappear, leaving you 1 over negative 1, which is negative 1. So this whole thing is really negative 1. So no matter what I plug in for x, I'll get negative 1. If you plug 10 in for x, you get negative 1. If you plug 1,000 in for x, you get negative 1. So don't forget, though, when these cancel out, there's still 1 on top. And there's my answer.